2.5 is on linear regression, and this one's going to be really short because I can't show you the calculator physically in the way these videos are made. So we'll do a lot of that in class, either on Tuesday and or on Thursday. So I may start it on Tuesday so that you can bring me more questions on Thursday. This is all about fitting lines to data. Data, it can be random, and you can have a whole lot of data points and you want a linear fit, and if you have 8 or so data points, you're not going to be able to match all 8 data points to a line, usually, because it's so random. So in order to have a model that is going to reasonably match the data without matching every single data point, we can use different models to approximate that relationship, and that's using your best fit specifically. So I guess the question being, like, how do we determine what best is? In terms of how it's done in your calculator, it's trying to ensure that the line is as close as possible to all of the data points. The form that we're going to be using is called a least squares fit, which is looking at the sum of the squares of the error. So, and your error in this case could be considered the difference between the line and the data point. So this little red blob that I'm putting, right, these little lines, that distance corresponds with your error between the data points and the fit. And the least squares takes the square of that error and then adds all of them together for every single data point. Luckily, you don't have to do that because it's programmed into your calculator. This is just written out what you would do on your calculator. We'll do it in class. Use the stat button, and then under edit, you'll edit the table entries for what is X and Y in order for it to construct the fit. And then when you hit stat, again, calc, you'll use linear regression, this linreg ax plus b, in order to run it, and it'll run through its program to determine A and B using that error analysis. And then the calculator will just pop out a value for A and a value for B, and then that's your linear fit, y equals ax plus b. We'll do some examples in class so you can compare the results that you get with your calculator to the actual function, and you can see how good or bad it is based on the data set that you have. We'll talk about correlation coefficient and a few other things. But yeah, see you in class.